Right heading thermodynamics. Then in chemistry also you have same chapter. Heading right thermodynamics. So, thermo means heat, dynamics means motion, and if there is motion, there is work. So that branch of physics which deals with heat, energy, and work is called as thermodynamics. Right, thermodynamics. The branch of physics which deals with heat, energy, and work is called as thermodynamics. That branch of physics which deals with heat, energy, and work is called as thermodynamics. Right?
Yes, sir.
Yes, sir.
What is meaning of thermal equilibrium? Equilibrium means what? Equal means equilibrium, na? No less, no more. So there are four types of equilibrium: thermal equilibrium, mechanical equilibrium, chemical equilibrium, thermodynamic equilibrium. We are dealing with thermal equilibrium. Thermal means temperature. So if the temperature of two objects are same, then we say they are in thermal equilibrium. So when temperature of system is constant, then it is said to be in thermal equilibrium. So if two bodies are in thermal equilibrium means their temperature is same. Better?
Yes, sir.
Now zeroth zeroth law of thermodynamics, first law of thermodynamics, and second law of thermodynamics. Zeroth law of thermodynamics. This deals with actually concept of temperature or internal energy. See, if A is equal to B and B equal to C, can I say A equal to C?
Yes, sir.
Yes, sir.
So yes, yes. Suppose there are three systems A, B, C, तीन system. If A is in equilibrium with C, मतलब दोनों का temperature same to same. A is also in equilibrium with B. That means B and C are also in thermal equilibrium. Like A is B, A is also C, then we can say B is same as C. Hello?
Yes, sir.
So that means if two system like B and C are two system are in equilibrium with A, then they are in equilibrium with each other. This is called zeroth law of thermodynamics. If two systems are in thermal equilibrium with third system, then they are in thermal equilibrium with each other. The diagram of zeroth law is as shown below. Right, zeroth law. When two systems are each in thermal, when two systems are each in thermal equilibrium, are each in thermal equilibrium, when two systems are each in thermal equilibrium with a third system, then they are in thermal equilibrium with each other. This is known as zeroth law of thermodynamics. When two systems are in thermal equilibrium with third, then they are in thermal equilibrium with each other. This is known as zeroth law, and below that draw that diagram. Completed?
Yes, sir.
Yes, sir.
Okay. Let's state first law of thermodynamics. State first law of thermodynamics. See, when we say internal energy means we are talking about temperature. And when we are telling about volume means we are doing work. So according to first law of thermodynamics, according to first law of thermodynamics, the amount of heat supplied to a thermodynamic system or thermodynamical system is amount of heat supplied to thermodynamical system is utilized for two purposes. First one, to increase internal energy denoted by du. Second, to perform work against external atmospheric pressure. To perform work against external atmospheric pressure denoted by dW. Okay, just copy this, then I'm writing that formula for first law of thermodynamics. Heat supplied is used for two purposes: to increase internal energy and to do work. Internal energy means temperature will increase, work means it will expand. So first we'll study zeroth law, first law thermodynamics, second law, then applications.
Done, sir.
So heat supplied according to first law of thermodynamics is used for two purposes: to increase the internal energy, that means temperature, and to increase volume, that means work done. So we can say therefore dq equals to du plus dw. So we can say first law deals with internal energy, that means temperature. Zeroth law deals with internal energy or temperature, and first law is law of conservation of energy. First law is similar to law of conservation of energy. Write this three line. Sometimes in MCQ they can say first law of thermodynamics is same as what? Law of conservation of energy. And zeroth law is nothing but concept of internal energy or temperature. Yes, written. Yes, written full.
Yes, sir.
Yes, sir.
Okay. So we got zeroth law. We know first law. Now second law of thermodynamics. Second law of thermodynamics. According to second law of thermodynamics, the first law said that entire energy is converted into two forms, work and internal energy. But second law says कि कुछ तो loss होगा. According to second law of thermodynamics, it is impossible to extract an amount of heat QH from a hot reservoir and use it all to do all to do work W, some amount of heat Q C must be exhausted, means lost, must be exhausted to a cold reservoir. So entire heat is not converted into work, but some heat is lost or exhausted to cold reservoir. This prohibits the possibility of a perfect heat engine. That means the entire heat cannot be converted into work. There is some loss. Okay, just write this, then one by one on the different laws we'll see some derivations. Okay.
Yes, sir.
So what is zeroth law? What zeroth law states?
When two systems are in equilibrium, they are in equilibrium with the third system, then all are in equilibrium.
Then they are in equilibrium with each other. It is gives the concept of internal energy, that is temperature. And first law, heat supplied is used for two purposes: to increase internal energy du and to perform work dw. It is based on law of conservation of energy. Second law, entire heat extracted from hot reservoir cannot be converted into work. Some heat is exhausted into cold reservoir. Hence, it prohibits the existence of perfect heat engine. Okay. Now, derive expression for work done during isothermal expansion. Derive expression for work done during isothermal expansion. What is meaning of isothermal? Temperature is constant or variable?
Constant.
So can I say for isothermal condition, temperature is constant. Hence, change in internal energy du equals to 0. Let Pi, Vi and Pf, Vf be the initial and final pressure and volume of gas at constant temperature. Most of the colleges, they ask this derivation. Right. For isothermal condition, temperature is constant, therefore entire internal energy is 0. So total heat supplied is only utilized to do work. Yes, done.
Yes, sir.
Okay. Now be careful. Huh? Consider isothermal infinitesimal small expansion of gas. Infinitesimal means very small. Therefore, work done TW is PdV. Therefore, total work done, comma W is integral of dW from initial volume to final volume. So we can say work done is PdV from initial volume to final volume. But for an ideal gas, PV equals to nRT. Therefore, P is nRT upon V. So W will be nRT upon V dV from initial to final. N constant, R constant, isothermal T constant, dV upon V from initial to final. Any of you know what is integration of 1 upon x? Integration of 1 upon x is log x. So here it is log V from initial to final. Copy this much. Consider isothermal infinitesimal small. Isothermal means temperature constant. So it is such that very small pressure is almost constant and volume is changing by dV. Completed full till nRT log V?
Yes, sir.
Okay. Shall I clear full?
Yes, sir.
Okay. So we got work done is nRT log. To simplify this, you put upper value log of final minus log of initial. What is log A minus log B? It is log of A upon log of B. This is formula for log A log B. Here no base is there means E. So we can write nRT. It is called natural log V final upon V initial, or 2.303 nRT log to the base 10 V final upon V initial. This is expression for work done. Now for isothermal condition by first law of thermodynamics, Q equals to U plus W, but U is 0. So we can say heat supplied at isothermal condition is nothing but work done, which is nRT natural log of final upon initial volume. If they ask derive expression for heat, then you will write this two line. Otherwise, W is nRT natural log V final upon V initial. 100% this will come if your teacher has done this chapter. Copy till end. Yes, done.
Yes, sir.
Okay. No. since for isothermal condition by Boyle's law, V initial equals to P final V final. Therefore, V final upon V initial equals to P initial upon P final. Therefore, W is equals to nRT natural log P initial upon P final. So we can also write work done in terms of pressure P initial upon P final in place of volume. Second, the entire heat is converted into work in isothermal condition. So when gas expands, then volume increases. Hence, work done is positive. That is, Q is positive. So when heat is absorbed by gas, it takes the gas, heat expands, heat is positive, work done is positive. When gas is compressed, then volume decreases. Hence, work done is negative. So for numerical, you should remember when to take positive, negative. If heat is taken in, Q is positive. Heat is given out, Q is negative. Same way when gas expands, W is positive. When contracts or compressed, negative. Write note. Shall I clear this?
Yes.
Fifth point. Change in state or phase takes place at constant temperature. Change in state or phase takes place at constant temperature. Hence, it is isothermal process. So solid becoming liquid or liquid becoming gas at constant temperature is isothermal process. The graph of PV at constant temperature is at constant temperature is called as isotherm. It is as shown. So graph of P against V is rectangular hyperbola called as isotherm. Write this and draw diagram. V initial, V final. Similarly here P initial, P final. B has coordinate P final, V final, A has coordinate P initial, V initial.
Done, sir.
So this much revise. One more lecture. Almost whatever is there in the syllabus this year, because many things is related.